I will be presenting to you the research that my colleagues and I did on the functional classification of the Gauteng provincial road network using the South African Road Classification and Access Management Manual. Okay. This study was done for the Gauteng Provincial Department of Roads and Transport in order to assess the current state of the road asset management system, as well as to provide a means in which to monitor and maintain it. This is integral for the Financial Assets Registry. I will give you a brief introduction and background to the study, as well as highlight the objectives and the methodology used to achieve them. The results will then be discussed and the areas of attention highlighted in the conclusion. Okay. The Committee of Transport officials states that an optimal road network is one that is congruent to its land use, as the land use determines the factors involved for the type of class that should run through it. The economic situation that South Africa finds itself in calls for a road network that links these land uses effectively, whilst being safe and efficient for societal use at the same time. The physical structure of the network affects driver behavior, energy consumption, and the environmental impacts associated with the emissions thereof. The study had 3 objectives: to acquire accurate and up-to-date spatial data, to develop a geographic information system workflow to prepare this data to include a variety of important attributes that indicate the current state of the Gauteng Provincial Road Network Inventory, or RNI as I'll call it from here forward, and to functionally classify each road within the RNI according to the TRH-26 manual. The TRH-26 guidelines ensured that all classifications were made according to the Road Infrastructure Strategic Framework of South Africa, standards put forth by the Department of Transport to be used nationally. Studies on road networks began abroad in the 1960s and focused mainly on the topology of the landscape. Today we have GIS, large amounts of data, vastly improved computational capacity, and modeling capabilities to perform such network analysis. Functional road classification involves the grouping of every road within a road network according to its structure and the service it provides, which primarily addresses aspects of access and mobility. An access road is defined as a road that crosses or is connected to a public road. An access road will give the driver access to services and facilities via ramps, driveways, etc. Mobility roads are designed solely to promote vehicle movement, and these are your freeways, highways, and primary arterials. It can be seen in the diagram that land access is characterized by local and collector streets, and the order of road increases as the function serves more for mobility purpose. Having the correct combination of function and order, road order, increases the efficiency of the road. The product of the study was ultimately used to update the Financial Assets Registry in order to qualify for funds from the Provincial Roads Maintenance Grant, which is used for essential maintenance of roads and bridges. According to the Division of the Revenue Bill of 2013, grants provided from the 2015-2016 financial year will be based solely on the performance of the RAMs in place. The study was conducted using the Gauteng Provincial Road Network for 2013 and 2014, consisting of 5,781 kilometers of road infrastructure. Despite its small area, Gauteng is home to over 12 million people and contributes significantly to the South African economy as well as the African GDP. For this reason, access to services and mobility to areas of employment and social activity is crucial. The roads were clipped to the Gauteng boundary and confirmed ownership by the GPDRT. All municipal and SANRAL roads and pathways were excluded from the study. The source data supplied by the GPDRT was in survey point format and had to be converted to line features, which encompassed a number of attributes inherited from the 2010 functional classification. The nodes and their unique identifiers in the 2010 dataset had not yet been captured as a point dataset and were only available through the attribute table. Dual carriageways also appeared in the attribute table of the 2010 dataset, but were to be correctly captured as separate entities digitally. All data processing was done on Esri ArcMap 10.3, using supporting imagery that included the 2012 South African National Spot 5 mosaic, NGI aerial photography, and Esri base layers, which included the 2014 Afrigis Road Centerline dataset, cadastral information, and recent dwelling inventories. The dwelling inventories were processed to determine the rural-urban boundaries and highlights residential and non-residential growth nodes, and this included the ESCOM SBC data over a number of years and the GTI building-based land use datasets for 2001 and 2010. The TRH26 provided the road classification criteria for the study. The two Gauteng provincial datasets used were the roads dataset for 2010 and the survey dataset. The new road network had to be represented by true center lines. Therefore, caution was taken in order to accurately represent these roads. This was achieved by using up-to-date, high-resolution satellite and aerial imagery in conjunction with the Afrigest Road Centerlines 2014 dataset. Dual carriageways had to be updated as two distinct separating and converging centerlines per dual carriageway as opposed to single entities. A well-established road network consists of nodes and links which together display topological and geometric changes. The nodes denote locations in a function of space, whilst the links denote the active connections of the road network. Each road was considered individually, and nodes were added to each provincial intersection where administrative boundaries were crossed and where surface type of the road changed. The line feature between captured nodes then became the road links, which were classified according to its location and properties. Each node and link was given its own unique descriptive identifier, and lengths of each link were calculated and recorded. A number of new nodes needed to be added to the dataset. These were named according to its proximity to the existing nodes and are yet to be given a unique identifier code. Certain intersections had insufficient existing nodes to fulfill this task, and so a systematic alphabetical approach was devised to capture the new nodes per intersection. If a new node needed to be added out of an intersection, the name of the closest node, as well as an N placed in front of it, was used to name the new road. As the 2010 dataset only represented dual carriageways as a single centerline, all dual carriageways needed to be upgraded from a single node to up to 4 nodes. The node allocation and spatial location thereof aided in distinguishing the road segments as primarily access or mobility routes. Each link was described according to the direction in which it is serviced, and the surface type thereof was recorded during this process as well. The first distinction according to the TRH26 that was made was whether the road belonged to a rural or urban area, and this was decided by observing whether the road was close to or contained by the development boundary, as well as by considering the underlying residential and non-residential kernel densities derived from the building inventories. Thereafter, 6 classifications were made: principal arterial, minor arterial, major arterial, collector road, local road, and walkway. The classifications were named U1 to 6 and R1 to 6 according to the rural or urban nature of the road, along with the order of the road. Walkways were not classified in the study as only provincial roads were used. An effective road network encompasses roads that provide adequate connectivity and mobility between land uses. The nodes and links created a visual representation of the spatial connectivity and mobility of the entire road network. This final product shows the Gauteng RNI split into respective nodes and links. More nodes exist in busier areas with numerous intersections. A common misconception exists that if nodes are far apart and the associated links are fairly equal in length, then the road in question is homogeneous. However, it can be seen from the many attributes that most roads are heterogeneous in nature. 72% of the classified roads in Gauteng were of an urban nature. As previously mentioned, a number of new nodes needed to be added at intersections. In the first figure, node 1163 was available in the 2010 classification. It was then split into 1163 A to D as a single node was split into 4 with the intersecting of 2 dual carriageways. 8 new nodes needed to be placed in close proximity to node 1163 and were given the node ID of N1163 A through H, as there were no closer nodes to associate it with. These instances proved to be very challenging and required much care when correctly naming the new nodes, as well as describing the links affected. Also note that the dual carriageway is represented by its true center lines, allowing for each section to be treated individually. This is important because in the event of road works starting on one side before proceeding to the opposing carriageway, for example, the two roads would end up having different road surfaces and quality grades as the process of upgrade occurs. By using links, the asset registry can be updated according to the actual work being done. In the second figure, we look at the non-continuity of roads. Link kilometer start and end readings needed to be taken with extreme care, as some roads discontinue at intersections with other roads and recontinue in different locations. The link kilometers of the recontinuing road would then have to start from the discontinued link kilometer. Roads that contain the addition of new links and/or nodes require that all road links be recalculated and the link descriptions updated accordingly. The 2010 dataset contained significant errors in the link calculations and representations, and so the 2013-2014 upgrade provided a more accurate representation of the current links and lengths thereof. The total length of provincial road links in 2010 was 5,074.2 kilometers, which increased by almost 14% in just 3 to 4 years. This highlights the dynamic nature of road infrastructure development and shows the importance of upgrading the RAMs annually. The process of accurately representing the road center line spatially was largely a manual process. In 2010, the 2010 dataset was the last available functional classification to make reference to. And so after a 4-year lapse, there were many changes within the road infrastructure. Not only does the manual interpretation contribute to an element of human error, but the process proved to be tedious and time-consuming as well. The GIS workflow developed, accompanied by the TRH-26, allowed for a systematic approach to upgrading the provincial RNI whilst providing clear-cut decision-making rules for the classification process. In certain instances, the road classification differed from link to link if the function changed from rural to urban or vice versa, but this was accounted for as well in the guidelines. The results yielded from the study showed a great deal of information about the roads that our citizens use on a daily basis, as well as how they have developed according to traffic pressures since 2010. The importance of having the system in place for every province is important, as it will allow for inferences to be made on a number of factors such as road safety and road accident volumes, and at the same time highlighting areas where road network needs attention. It was also found that the shorter links of 400 meters or less, and in most cases between two dual carriageways, represented bridges, which was confirmed in the 2010 road name attribute field. These can be confirmed visually using satellite imagery. The spatial location of bridges forms part of the bridge management system, which is a subcomponent of the road asset management system. The bridge management system, RNI, and traffic counts allow for the financial asset registry to show a true representation of the assets in question. So in conclusion, the TRH-26 offers a standardized measure of classification that has been used previously in KZN and Cape Town and can be adopted in every province and the results compared and contrasted. In 2003, SANRAL stated that all access to national roads will be classified in accordance to the national guidelines for road access management in South Africa manual. In this respect, standardization of functional road classification is standardized. This study proved that the functional classification method guidelined by the TRH-26 is efficient as the attributes are easily attainable despite the manual calculations that need to be done. The attributes provide a comprehensive state of the network, which allows for other studies to use this data in a variety of other applications. As many of the attributes were quantifiable, the routine maintenance of RNI, through the routine maintenance of RNI, one can track the development of the network both spatially and temporally. Since a node policy did not exist prior to the study, a protocol had to be agreed upon and was followed. However, further attention needs to be given to this aspect as new roads will continuously be added to the road network. An updated RNI increases the accuracy of condition assessments of the roads, traffic studies, and analyses. An up-to-date classified road network impacts areas of finance, maintenance, and construction, which allows for optimal and efficient urban and rural development. The project also serves as the CSIR's contribution to the TRH guidelines as a working document to be updated with every future classification, as situations change and data can be better represented. That's the link to the public viewer. So if any of you are interested in looking at the data, you can find it at that URL. Thank you.
Thank you. Very interesting.